Welcome to today's Explainer. We're opening up an official case file review today, and honestly, it's a somber but absolutely crucial one. We are going to do a forensic dive into the January 2026 Woodland Pulp Hydrogen Sulfide release. When we look at these industrial disasters, we aren't just looking at broken pipes or chemical formulas. We're looking at human lives, systemic safety culture, and the hard lessons we literally have to learn to keep history from repeating itself. To guide us through this, we're relying on an official briefing prepared under my brand, The Investigator's Eye, or Ain al-Mohakik. I'm Tamer Abdellah Sharaki, a certified safety manager, safety consultant, and accident investigation expert. Being a member of the NFPA, the International Association of Emergency Managers, and IMR EST, my goal here is to bring that professional, forensic lens to the table. We need to dissect exactly what went wrong and truly understand the cascading failures at play. All right, let's jump right into our agenda. We'll start with the Investigator's Eye, move on to the Woodland Pulp Mill setup, break down the chemistry of a disaster, walk through the timeline of the release, examine the critical safety gaps, and wrap up with findings and lessons learned. Starting with Section 1, The Investigator's Eye, Analyzing a Tragedy. We've got to look at the raw facts to figure out how a routine operation turned deadly in Bailey Ville, Maine. Our core data comes straight from the ongoing probe by the U.S. Chemical Safety and Hazard Investigation Board, or CSB. They were brought in to investigate this catastrophic toxic gas release that tragically claimed the lives of 2 workers. And the CSB's role here is absolutely vital. They don't just figure out what happened. They dig into why the safety systems that were supposed to protect those workers completely failed. Moving on to Section 2, the Woodland Pulp Mill, Operations and Infrastructure. To really get at that why, we need to see how normal everyday infrastructure inadvertently set the stage for a disaster. Right at the heart of this facility is the kraft mill. It's a 4-story building housing the bleach plant, which is where wood pulp gets chemically weightened. Now, during normal operations, this process generates liquid waste. That waste drains down a massive 1,000-foot-long gravity-fed acid sewer pipe, sending it straight toward the wastewater treatment plant. The fluids flowing through there are usually highly alkaline, meaning high pH, and, this is key, they contain sulfur compounds. Now, here's where the infrastructure gets tricky. There's a specific spot in this pipe called an upward transition. Think of a pipe that mostly flows downhill by gravity, but at one section, it actually angles upward. Since gravity can't pull the liquid up and over without enough flow, this spot becomes a bottleneck. It acts like a low point where liquid chemicals just pool and accumulate instead of draining freely. Keep this spot in mind because it is literally ground zero for what happens next. That brings us to Section 3, Chemistry of a Disaster, a Lethal Combination. Let's shift over to the science and see how this lethal chain reaction was triggered. Let's break down this 4-step chemical reaction. It's actually pretty straightforward, but incredibly deadly. Step 1. The bleach plant shuts down, dumping a huge volume of basic, sulfur-rich fluids into the acid sewer. Step 2. Way down the line, a pH probe detects a sudden spike in alkalinity. To neutralize it, the system automatically injects sulfuric acid into the pipe. Step 3. That freshly injected acid flows back and hits those high pH, sulfur-rich fluids right where they've pooled at that upward transition we just talked about. And Step 4. Sulfuric acid mixing with high pH sulfur compounds causes a violent chemical reaction. The byproduct? A massive release of highly toxic hydrogen sulfide, or H2S gas. Here's the thing. Woodland Pulp actually knew this reaction was a possibility. Normally, if H2S forms in the pipe, a scrubber fan in the bleach plant acts like a giant vacuum to safely pull the gas out before it can reach the atmosphere. But here is the fatal flaw. Because the plant was in the middle of a shutdown, operators had actually turned that scrubber fan off. So, with the main defense mechanism completely disabled, this rapidly expanding, lethal gas had nowhere to go but up, out of the drains, and straight into the kraft mill building. Let's look at Section 4, Timeline of the Release, January 26th to 27th, 2026. We need to map out the chronology of these fatal hours. It all starts on January 26th, when management made a sudden call to shut down most of the mill because of a sharp spike in natural gas prices. Fast forward to the 27th. Between 12:30 and 2:30 a.m., operators drain the bleach plant, sending those sulfur compounds right into the sewer. At 4 a.m., the automated acid injection kicks in, starting that deadly reaction. Once the gas leak was eventually noticed, the crew jumped into emergency response mode. They manually shut off the acid and flushed the sewer with water. By 3 p.m., the toxic gas had finally dissipated. But it wasn't until 6:15 p.m., over 3 hours after the air cleared, that they made a devastating discovery. 2 employees were found collapsed on the second floor. Take a look at the CSB health effects chart. It really puts into perspective the terrifying environment those 2 workers unknowingly walked into. Hydrogen sulfide is notorious. At low levels, yeah, it smells like rotten eggs. But at high concentrations, it causes rapid olfactory fatigue. That means you instantly lose your sense of smell. You literally have no idea you're breathing in poison. And the CSB estimates these workers were exposed to concentrations well over 500 parts per million. Let me be clear, at 500 plus ppm, we're not talking about a bad smell or a mild cough. We're talking about the rapid onset of severe toxicity, staggering, unconsciousness, respiratory paralysis, and ultimately death. It's an aggressively lethal environment, which explains exactly why these workers collapsed right where they stood. Which brings us to Section 5, Critical Safety Gaps, the CSB findings. How on earth could 2 workers be exposed to 500 parts per million of toxic gas inside a modern facility? What's incredibly tragic here is the stark reality of the systemic failures. These 2 employees were on the second floor working on a drawing project that had absolutely nothing to do with the bleach plant shutdown. Yet, there was 0 personnel access control, no accounting system to track who was even in the building during this high-risk phase. On top of that, the craft mill had no building ventilation system to clear out hazardous air. But the most glaring, unforgivable gap? There were 0 stationary hydrogen sulfide detectors or alarms anywhere in the area. And the company didn't provide or even require personal H2S monitors. They had absolutely no warning systems. They were walking blind into an invisible threat. Finally, Section 6, Findings and Lessons Learned. Let's pull the major safety takeaways from this case file review. Take a look at this statement from CSB board member Sylvia Johnson. She points out Woodland Pulp was aware of the hazards, but despite this knowledge, the company did not have adequate systems in place to monitor or mitigate the hazards. And wow, does that hit the nail on the head? This adds real regulatory weight to a fundamental truth in safety engineering. Simply knowing a hazard exists in your facility is completely useless if you don't have robust, active mitigation systems in place. A sentence in a safety manual doesn't save lives. Detectors, ventilation, and strict access controls do. So that leaves us with a critical reflection for anyone out there in operations, management, or safety. We've just seen how a simple financial decision to shut down, combined with a pooling pipe and a lack of gas monitors, triggered a completely preventable tragedy. So I want you to look closely at your own operations. You know your hazards, but are you truly mitigating them? Are your safety systems actually active, or do they just exist on paper? Think about that. Thank you for joining me for this explainer, and please stay safe out there.